In this illustration here, we have 2 cups filled with water. On the left cup is hot water, and the right cup, the blue cup, is cold water. And we're going to see how the cold water is going to sink to the bottom of the tub, and the hot water rises to the top of the tub. This is creating a convection current where the cool liquid sinks and the hot liquid rises. We're going to be talking about today thermal expansion and how that's related to density, and then the types of convection currents that we see around our planet. Here we're going to look a little bit more at thermal expansion and how that relates to density. So we saw yesterday that the progression from a solid to a liquid to a gas energizes the molecules within the substance. So a solid has low thermal energy, and as you move toward a gas, we get higher thermal energy. And this is going to relate to the density of the particles themselves in the substance. So cold molecules, and density is just how tightly packed the molecules are. Cold molecules, they have low energy and they condense together. And whenever they are real dense like this, when the molecules are packed real tightly, that is high density. I think of this like the penguins in the Antarctic. When they get really, really cold, they all smush together in one big huddle. Now, warm molecules, they have high energy and they spread out. And this creates a very low density. And I think of this like if you just got done working out or something, or you're feeling hot and sweaty, you don't really want to be next to someone else that's hot and sweaty, right? You want to kind of push them away and you need your space. So warm molecules, they spread out. And this was illustrated in the demonstration right before this with the cold sinking water and the warm rising water. The cold water sunk to the bottom because its molecules were more tightly packed and it was denser, so it sunk. The warm molecules of water, they were more spread out and less dense, so that's why they rose on top. Denser substances are always, they sink to the bottom, and the less dense substances will stack on top of that. All right, because of the density differences in hot and cold objects, this creates convection currents in our Earth, and it has a lot of implications about what happens on Earth, this convection current. Remember, convection is the flow of heat from inside of a liquid or inside of a gas because of the temperature difference, because the warm water rises and the cold water sinks. This creates a convection current. Now, there's convection currents in the mantle of the Earth. So you guys should remember that at the center of the Earth, we'll just say right around here somewhere, is a very hot core. The iron core of the Earth is extremely hot. And then outside of the core is kind of like silly putty. It's the consistency of silly putty. It's called the mantle. So it moves. And what happens is right around the core of the Earth, the mantle, that silly putty material, gets extremely, extremely hot. It's just like, it's melted rock, basically, silly putty rock. And so it gets extremely hot, and we know that hot objects rise. So that hot mantle right here rises up to the surface toward the crust of the Earth. It says rising magma. So it's rising toward the crust of the Earth. Now, once it gets further away from the core, it's going to start cooling down. So it cools down and travels this direction, travels back to the core of the Earth, heats up, rises, cools off, and sinks. And we see a convection current that moves like this in the mantle of the Earth. Now, what this does is it causes seafloor spreading, because this current goes this way, and this current goes this way. Right here in the middle, the crust of the Earth actually splits apart, and this piece of crust travels this way, this piece of crust travels this way. And this rising magma comes right here and it forms new rock. This is called seafloor spreading. This is what makes our continents move around the Earth. And it actually, these move at about the same rate as your fingernails grow. this picture here is the Mid-Atlantic Ridge. It's this here that runs between North America and Europe and South America and Africa. This is a ridge of seafloor spreading where that uprising mantle, that magma, rises to the top and spreads out the crust of the floor. And this, on the right side of this ridge, all of this crust is moving to the right. And on the left side of the ridge, all of this crust is moving toward the left, which is why this has spread apart, and it continues to spread at about the rate that your fingernails are growing, which is why all of our continents are continually moving because of seafloor spreading and the convection currents in the earth. Another place we see convection currents on our earth is in our oceans. So this illustration shows the world. This is Antarctica down here. And we know that when the Antarctic ice melts, it's very, very cold. And because it's cold, it's very dense. So that water immediately, whenever it comes off of that continent, sinks straight to the bottom of the ocean. And when it sinks to the bottom of the ocean, it pushes the other water that's already there out of the way. So that cold water sinks to the bottom and pushes some of the water this way. And these currents are fixed around the earth. So as that other water gets pushed this way, it travels toward the equator where the water is warmer. The air is warmer. So it starts to rise up. And as that warmer water rises, it travels kind of along the equator, warm, shallow water, you can see here. And then as it comes to the top of the planet, up toward the Arctic, it cools off again, sinks to the bottom, comes back toward Antarctica, where this water is sinking also, travels back up, warms up, rises to the top of the ocean, travels around the world, sinks back down to the bottom, and this is how we get our currents in the ocean. You guys probably have seen Finding Nemo. I think they had those little turtles, they travel the Australian current, the East Australian current, and you saw that current in the movie made those turtles travel real fast. If you haven't seen it, you should watch it. But these currents are fixed. It's because that cold water is constantly sinking and the warm water is constantly rising, and it creates kind of a conveyor belt in the oceans because of convection.